So here we have a grocery store manager recording the number of people in checkout lines at several different times over the course of a month. She creates a frequency distribution for the number of people in line X. So your random variable X is the number of people that she observed in line, and the F is the number of times she recorded that many people. So there's a total of 380 observations that she made. So that first row, 0 people, occurred on 34 of the observations. So on 34 of the occasions, there were 0 people in line. Number 2, to create the probability distribution P of X, all that P of X is the relative frequency of each of the X values. So there were 380 total. So take 34 divided by 380, and that gives you 0.8095. 40 divided by 380 is 0.1053. So after you divide all of the individual frequencies by 380, you get the P of X column. In number 3, to find the mean, median, mode, number of people in line, the mean of a probability distribution is the sum of X times P of X. So you need to find X times P of X for each of the rows. So 0 times 0.8095 gives you 0. 1 times 0.1053 gives you 0.1053. So do X times P of X for each of those values, and then add them up, and that sum is 2.866. The mode is the one that occurs most often. You'll notice that 4 occurred 90 times, which is the most. So 4 is the mode. And then the median is the middle number. There's 380 data values. So if you take that divided by 2, that's 190, which would mean there's 190 data values on each side of the median. That would leave nothing left in the middle, so you have to average the middle two values, the 190th and 191st. So as you count down from the very top of the distribution, 34 and 40 is 74. Add 86 to that, you get 160. So the 190th and 191st values will both occur in this row here when X is 3. So the median will be 3. And then the standard deviation, one way you can find that, I don't suggest you try it by hand, but if you enter your X and P of X into your calculator, into list 1 and list 2, and then you can calculate the 1-bar stats. So stat, calculate 1-bar stats using list 1 and list 2. Notice that gives us the mean of 2.865 again. Standard deviation of 1.575, which is a little off from what I had here, probably because of the rounding in the table. The other thing I want to point out is that the mean of 2.865, that hopefully makes sense. One thing I see students miss a lot in this is they see these large frequencies and they think that means that the mean has to be a fairly large number. But remember, you're finding the mean of the X values, and your only X values are between 0 and 6. So all of your descriptive statistics, your mean, median, mode, have to all be between 0 and 6. So just keep that in mind. Okay, and then finding the probabilities, this is just from using the table. So the probability that X equals 4, well, there were 90 out of 380 that had exactly 4 people in line, so that's 0.2368. If X is less than 2, that's a probability of 0 plus the probability of 1. And that was 74 out of 380. That's from adding 34 and 40. Now you could also just add the P of X column, the values in that. And because of rounding, it might be slightly different, but they should be very close to each other. Okay, and then number 7, 145 out of 380, or 0.3816. And then finally number 8, this is just a mean of a probability distribution in disguise. You have a raffle that has 1,000 tickets for sale. They cost $5 each. You have a $1,000 winner, a $500 winner, and then 10 $100 winners. If you buy one ticket, what's the expected value of your gain? So if you take X and then the probability of that X occurring, X represents the gain when you buy a ticket. So -5. So if you buy a ticket, you have to pay $5 for it. 988 of those tickets are losers out of the 1,000. So the probability of losing $5 is 988 out of 1,000. The 995 comes from the $1,000 winner. Remember, if you buy that ticket that has the $1,000 winner on it, you had to pay $5 for that ticket. So 995 is your actual gain. And that has a probability of 1 out of 1,000. The 495 is arrived at a similar manner. And then the 95, well, there's 10 $100 winners. So you have a chance to win $95 10 out of 1,000 times, because there's 10 of those winners. So when you take X times P of X, so multiply -5 times the probability of -5, and then add 1 over 1,000 times 995. I simplified that and just wrote it as 995 over 1,000. And then 495 times 1 over 1,000 is 495 over 1,000, and so on. So when you do those calculations, you have -4.94 plus 0.995. Make sure that first one was negative. Add the rest of them, and you end up with -250. So you expect to lose $2.50 when you buy a ticket.